All right, now that we've determined how to figure out how to see the amount of significant figures, let's apply this knowledge to multiplication, division, addition, and subtraction. So first of all, let's look at multiplication and division. And we're looking at this is the rule for us: round or add zeros to the calculated answer until you have the same number of significant figures as the measurement with the fewest significant figures. So what does that mean? If you have used a ruler or something, you have 3.34 centimeters, and you're multiplying that by something that you only have significance of like 1 decimal, 5.1 centimeters. When you multiply those two together, you would end up getting, go ahead and do that calculation. So 3.34 times 5.1 would give you 17.034 centimeters squared. That's a little too much accuracy that we don't necessarily have based on our instruments. So you have 1, 2, 3 sig figs, 1, 2 sig figs. Our answer is only going to have 2 significant figures. So based on the measurement with the lowest amount of significant figures, that's going to be the same thing. So you're going to look at this number and round it to 2 sig figs. It would be 17 centimeters squared. Do another example. Let's say you have 5.15 grams, and I'm going to divide that by 60.432 milliliters. So when I end up doing that, if I just take those numbers and do 5.15 divided by 60.432, I would end up getting a number something like 0.0852197.5 grams per milliliter. Notice this only has 1, 2, 3 significant figures, 1, 2, 3, 4, 5. So our answer is going to be rounded to the 3 significant figures, which is the least amount there. So it'd be 0.0852 grams per milliliter, which would be more accurate than what we're looking at there. So that's multiplication and division. I'll do another example here and see what you guys can think. How many, if I just give you a number like 60.5 and multiply that by 2, if you just did that math, you'd end up getting 121. And notice this has 1, 2, 3 significant figures. This has 1 significant figure. So what do you think your answer should be? I know this is kind of hard to think about, but you actually just round it to 100. I know that's painful to even think about, but that's 1 significant figure. Your answer should be 100. All right, let's continue on looking at addition and subtraction. So addition and subtraction doesn't necessarily have to do with the amount of significant figures. It has to do with the amount of decimal points that are present. So the answer has the same amount of decimal places as the measurement with the fewest decimal places. So I take this 10.53 and I add 5.7. When I do that math, just typical in a math class, it'd be 3, 2, 16.23. What we say using our ideas of limited measurement would take the answer and round it to the number that has the least amount of decimal points. This has 1 decimal point, that has 2. Your answer therefore is going to have 1. So you take this 16.23 and round it to 16.2. In subtraction, it's the same kind of idea. You have 50.65, subtract 10. Let's make it 11. And when you do that, you get 5, 6, 30, 39.65. But in looking at this, once again, we round to the nearest significant figure. If we're looking at the amount of decimal points, there's 2, there's none, so our answer is going to have no decimal points. You would just kind of take this and round it to no decimal points, which would be 40. But notice that this decimal point is going to be a significant decimal, so you need to either put a decimal there or you could underline it just to say that that 0 is significant. So you have 40 is the answer there. Let's do another one. So I'm going to give you 101 minus 5.65. What do you think your answer would be based on significant figures? and the decimal rule. Yeah, let's look. So you'd have 5, 3, 5, 9, 95.35. If you just put that into a calculator, that's what you get. But the answer is not that. It's dependent upon no decimals, 2 decimals. So our answer is going to have no decimals. Round that to no decimals, 95. Great. So that's addition, subtraction, multiplication, division based on significant figures as well as decimal points. One more thing I want to go over quickly is this idea of scientific notation. So what is scientific notation? We have decimal notation, which is normal, just like 500, 5,231. But you can convert that into scientific notation, which is more like 5.231 times 10 to the third. So let's take a look at why we'd be useful, why this would be useful. Well, how wide is the universe? You're like, well, of course, it's that number of miles. But will we want to walk around and say that huge number? No, we're going to convert that into scientific notation. In order to do that, we take a decimal point, which would theoretically be there. We're going to move that decimal point to a place that will make this number between 1 and 10. So 2.1 times 10 to some power, 2.1 times 10 to the power of however many decimal points we need to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23rd power. So that number is much easier to write out and use than this really large number here. So that's a reason that we would use scientific notation. So scientific notation is a number expressed in scientific notation when it is written in the form of A. A is just a digit between 1 and 10. So it could be like 9.9. It could be 1.1. Anything in between 1 and 10. Times 10 to the power of n. N is going to be an integer, and that's just a negative or positive whole number. Great. So let's just kind of take a look at this example. Express this number, which is really small, in scientific notation. So it has to do with where can we move this decimal point to make this number between 1 and 10. If I can move this decimal point 1, 2, 3, 4, 5, 6, 7, 8 places to the right, this number looks now like a number between 1 and 10, 9.02 times 10 to the 8th, or negative 8th, because it's a small number, and you move that decimal to the right. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8th. If I give you this number, 902, 1, 2, 3, 4, 5, how could you write that in scientific notation? Well, you take this. Decimal point should theoretically be here. 1, 2, 3, 4, 5, 6, 7, 8. 9.02 times 10 to the 8th. So positive number is going to be big. Negative number is going to be a small number. So how can you write this in scientific notation? Give you guys a second to try to figure that out. Hopefully you got used to move this decimal 1, 2, 3, 4. 2.87509 times 10 to the 4th power. Excellent. So we're going to do a lot more practice with these on a worksheet tomorrow. Hopefully this is helpful, and let me know if you have any questions.